Right now, 25 billion kilometers away, a silent machine is slowly freezing to death in the endless dark. The spacecraft is powered by a decaying piece of plutonium. After nearly 50 years of continuous operation, that heat source is cooling, causing the probe to lose about 4 watts of electrical power every single year. To keep the core systems running, NASA engineers are executing a strict triage protocol. They are systematically shutting down instruments that have been operating flawlessly for half a century, pulling the plug on cameras, shutting down its spectrometers and plasma sensors, one by one. To buy a few more months of life, Voyager must deliberately blind and deafen itself, sacrificing its ability to feel the universe around it just to stay awake a little longer. By the year 2030, the available power will drop below the absolute minimum threshold required to operate the radio transmitter. On that day, engineers will sit at their consoles and send one final command. Because of the immense distance, they will have to wait a full 24 hours for that signal to reach the spacecraft. When it does, humanity's longest continuous conversation will go quiet. For us, the mission is over. We lose a probe. But out in the vacuum, the machine won't stop moving. Freed from its scientific duties, it transitions into a silent, eternal cosmic message in a bottle. 300 years from now, long after everyone who built it is gone, Voyager will reach the inner edge of the Oort Cloud. This is a vast, invisible spherical shell of icy debris left over from the formation of our solar system, wrapping completely around our cosmic neighborhood. This diagram compares a dense Hollywood-style asteroid field with the reality of the Oort Cloud. There are billions of frozen chunks here, but the average distance between them is tens of millions of kilometers. Voyager will spend 30,000 years flying entirely through this debris field in complete silence. Eventually, it will pierce the outer boundary of that icy shell. At that precise distance, the gravitational pull of other stars will finally become stronger than the pull of our Sun. That shift in gravity severs the final physical tether holding the spacecraft to its home. The machine officially leaves the solar system's grip, becoming a true cosmic orphan. Over the next few million years, Voyager will adopt a new path, orbiting the massive center of the Milky Way galaxy. It will occasionally pass near neighboring systems, like a small red dwarf star named Gliese 445, gliding harmlessly through the empty space between them. 5 billion years into the future, the solar system it left behind will face its end. The Sun will exhaust its primary fuel and begin to swell into a red giant, expanding outward to swallow Mercury, Venus, and everything in its immediate path. As the expanding Sun closes in, Earth's oceans will boil into steam, the atmosphere will ignite, and the planet will be reduced to a scorched cinder of rock. At that moment, the golden record strapped to Voyager's side becomes a flying tombstone. Drifting billions of miles away, those grooved copper tracks will be the only remaining physical evidence that Earth and its people ever existed. Billions of years further into the dark, our entire Milky Way will collide with its massive neighbor, the Andromeda Galaxy. This diagram illustrates the counterintuitive physics of galactic mergers. Because interstellar space is overwhelmingly empty, these two immense structures will pass directly through each other. The stars and planets within them will almost never physically collide. Caught in this merger, Voyager will be violently tossed into a new chaotic trajectory by shifting gravitational waves. Yet amidst all that cosmic violence, it will slip through the storm completely untouched. This small piece of carved metal and wire, built in a matter of months by human hands, will survive the death of the very galaxy that birthed it. Trillions of years later, the universe will approach the end of the stelliferous era. The raw hydrogen gas required to form new stars will be completely exhausted. With no new stars being born, the last remaining lights in the universe, small, incredibly slow-burning red dwarfs, will run out of fuel and fade into darkness, one by one. The cosmos will become an unimaginably vast, pitch-black graveyard, populated entirely by the cold, dense husks of dead stars and silent black holes. Yet, gliding blindly through that frozen, dead expanse, a faded, scratched Voyager will still move forward. The final chapter of this journey relies on a theoretical physics concept called proton decay. In roughly 10 to 30 years, physicists hypothesize that matter itself will lose the ability to hold together. Under this theory, Voyager's hull, its wiring, and the golden record will begin to dissolve, breaking apart atom by atom into absolute nothingness. This brings into focus the true philosophy behind astronomer Carl Sagan's golden record. He never genuinely expected it to be intercepted by an alien civilization. The act of casting it into the cosmic ocean was the actual point. The Voyager mission was an act of profound, defiant hope. It was a fragile, fleeting species standing on a tiny rock, reaching out into the endless dark simply to declare, "We were here."